All right, tonight we are looking back at our secure backup drive. Now, I want to reiterate, we use this Kingston Data Traveler USB drive just for the sake of the demonstration. My actual reason for choosing this is because it's only 16 gigs. I'm stuffy, so it's hard to say 16 gigs.
Allergy season!
It's only 16 gigs, so it was really, really quick to pull together a presentation. We didn't have to wait to format a terabyte drive kind of thing. So that's my reason for choosing it. But you may be using an external hard drive. You may be using something over eSATA. It could even be an internal hard drive that you're doing this with. It doesn't really matter, but for our demonstration, we're using this USB drive. I just want to be clear that it can be anything as long as it's a partition in your Linux system. So tonight what we're going to learn, as I promised last week, is how can we now set this up so that it is accessible on our system without having to constantly enter the password. So what it boils down to is, hey, we want to back up our server, for example. Good example from this perspective. We want to have a drive that we can back up all of our server files to and then unmount it, take it somewhere, put it in a safety deposit box. So if it gets stolen along the way...
What do you store on your data sticks?
Me? A lot of video because of Category 5,
Safety
right?
deposit box?
Well, it's just an example. Let me do the example thing here, Jeff. So I put these out, and someone's going to go, oh, yeah, that's a good idea. Because, you know, here's why. You've got all your family photos on this. You've got them on your computer, and you feel confident that, hey, I've got 2 copies, and now if my computer fries, I'm safe. Right. And then the house burns down. And you don't ever want that to happen, obviously, but... having this somewhere else is a really good plan,
right?
If it's well away from everything else. So now, looking at the server idea, if I have a server set up that I want to back this up on my Linux server, that's my backup, and it copies all the files over, and then I can take it, and it's encrypted, so if someone steals it or it gets lost, they can't open the file, so it's still private. But the thing is if I plug that back into the server, maybe it doesn't have a monitor.
Right.
And I can't type the password, or I can't do those kinds of things. I want it to automatically mount to that system, or at least be able just to go sudo mount -a, and it will mount it, and I don't have to manually enter the password every time when connected to that server. But then still have it so that if I eject it from that, take it home, plug it into my home computer, I have to enter the password there.
Right.
For safety reasons, right?
Yep.
So tonight we're going to learn how to take this and make it so that we do not have to enter the password on our system. That could be the server, that could be our actual notebook, or whatever it is. Jeff, I'm sorry. We are going to have to look at some Luke's dumps tonight.
You know what? I think I got it out of my system last week.
You got
Yeah.
it? Okay.
Yep.
You watched back and you laughed hysterically a couple times. Did you show the kids?
I showed the kids.
Yeah,
I showed my wife. I spent time just having giggles to myself. I think I watched it like 4 or 5 times.
We all did.
I showed
to get it out of my system because I knew we were going.
We were
going
to be talking about. You have to like desensitize yourself. I showed Dave, and he's like, I need to spend more time on the show. Like, he wants to come watch live now, and every time he comes, I'm so nervous. I never say anything. Like, but yeah, it was so much fun.
Yeah.
Okay.
But it's out of my system. We're all good.
So that said, if you haven't seen it yet, this is part 2, and it is very much part 2. If you have not seen part 1 yet, please go back. I've got the link up there if you're watching on YouTube, or of course you can go to our website, category5.tv, and you can watch episode number 505. Make sure you do that first, okay? Otherwise, none of this is going to work. None of it's going to make sense.
So
okay.
What you're saying is this is the episode that's Luke's
the
Dump
continuation.
2?
2.0. Number 2.
Luke's Dump number 2.
Took me a sec. Okay, here we are on my computer. I'm going to plug in the USB flash drive here. And it should ask me for the password. Great, right? I'm going to say forget password immediately because we don't want to have to log out every time here on the air. So I'm going to enter my password. And if it all went well, there we go. No typos tonight, my friends. Okay, so what I want to do is make it so that I no longer have to do that. I don't want to have to enter a password every time I plug it into this computer. So let's see what we can do here. So bring up our terminal. We're doing everything to do with this particular tutorial in our Linux terminal. Cool? So I'm going to create a super user login by typing sudo su on my Debian or on my Ubuntu system. On Debian it would just be su, as we learned last week. So first of all, if you go into /root, you see there's nothing in that folder. There might be, I don't care, but I just wanted to show you that there is currently on my system nothing there. I'm going to create something though. I'm going to actually create a random key file. So it's a big, long, crazy binary string that's going to be used as a key, literally, like an actual key to unlock this drive. And we're going to add that to our key slot.
That on the screen?
I hope so.
I don't know. Maybe. We'll see. Depends on your GUI, but we're doing this in the terminal, Jeff.
All right.
Yeah. All right. So we're going to create that file. So we're going to go DD. That's like disk destroyer, disk duplicator, whatever you're doing with it. It can do both. In file equals /dev/random. Pardon me, dev/urandom, because we want it to be ultra random. Actually does not mean that. It just is a good way to do it. But a good way to remember, right? Ultra random. It's the better randomness. Okay, so out file, OF equals, and we're going to go, now I'm in the root folder, but just for the sake of being accurate, /root/ and we're going to call this my USB.key. Let's just do that. Now we're going to say BS. How much BS do we want this file to have?
A whole lot of BS.
Yeah, we're going to give it a whole lot of BS. That's 1024 is what we're going to do. And then the next count equals 4, and then hit enter. And what that's going to do is it's actually going to generate 1024 bits of data within this file. Check it out. I'm going to cat it. USB.key. It's already created. It was instant. So you see how much gibberish that is? That's actually our key. So good luck remembering it. Good luck typing that in if you're trying to hack into my flash drive.
I don't even know how to pronounce those boxes.
Yeah, you know.
That looks like something that you would actually put on the news desk. That's
on
what,
the teleprompter
yeah,
for you.
you do that.
She has to pronounce that tonight, folks.
He does things like this. Like, I hope you can get that name.
Yeah, that's the name of the guy who invented it. Yeah. So with that key, now we're going. We learned last week at the end of the show that we have when we create a LUKS dump, right? Crypt setup LUKS dump /dev/sd. I'm assuming this is still SDB. Oh, I may have to. I unmounted it, so it may be. I may have to unplug it and plug it back in again because the dev is actually gone. ls/dev/sd star. Now SDB1 is there. So okay. So if I do a LUKS dump. Sorry, Jeff.
It's all, like I said,
Crypt setup.
it's out of my system.
Is it?
It's all
okay, good. He's not snickering. But
Nope.
you're holding something in your hand and you're squishing it.
No, it's... I have to fidget. I'm a fidgeter, so it's
All
my
right.
USB. I'm spinning it.
That's your fidget spinner.
That's
It's-
your
yeah, it's my... yeah. That's
Crypt
right.
setup LUKS dump. Remember that from last week?
I do remember that.
Do you? Capital D. And /dev/sdb1. Enter. Okay, so what we learned at the end of this segment last week is that we've got key slot 0. That is the actual password for our device. That's when I plugged it in, it asked me for a password. That's key slot 0.
Okay.
Key slot 1 is currently disabled. So what I want to do is I want to actually add my key file, which I've just created, usb.key, to key slot 1. The way I'm going to do that is crypt setup. Remember, I am super user right now. LUKS add key dev/sdb1 in my case. It may be different for you. Don't forget that, okay? And then the key file is root/usb.key. Enter. This is asking me for my existing password now because guess what? Encryption's not going to let me add a key file that allows me to decrypt the drive if I don't already know the key.
Right. Makes
Right.
sense.
Otherwise, where's the security? Someone said on some forums, he said, I lost my password. Can I add a key file so that I can open the drive? Well, you lost your password, so how secure would it be if that was allowed?
Right.
Because then there's no security at all. Anyone could just add a key file and boom, they open your drive with just a little bit of know-how. So this is a lot more secure than that. Enter your existing password I only have the one, so that's why any existing password is the password.
Right.
So now it's actually uploading into the headers of that partition that key file. So now if I do a LUKS dump, you see key slot 1 is now enabled. So I can now open that drive, decrypt it using either of those two key slots. My password is key slot 0 and my key file is key slot 1. So those are both now attributed to that drive. I can open it with either or. Okay? So now what I need to do is you've heard of a UUID, a unique identifier for a drive, a partition. We need to know the unique identifier for our LUKS partition, our encrypted partition. So the command is a little bit different. It's not blkid. Instead, what we're going to do is crypt setup LUKS UUID /dev/sdb1. And that gives me the unique identifier for this particular drive. So I need to grab that. I'm lucky because I'm actually in a sort of a pseudo terminal window here, so I can actually copy and paste and grab things into my clipboard because I'm going to need that. There are other ways around that if you don't have a clipboard. I'm sure you can figure it out. You can write it down as long as you're very good at typing because you're going to need to put it in verbatim. Okay, so now we need to edit our crypt tab. Notice it's a crypt tab, not a FS tab. So we need to first set up that the cryptography decrypts this drive so that FS tab, our file system table, is able to mount it automatically. Okay, so /etc/crypt tab, it already exists, so I can just hit tab to enter it, but there's nothing in that file. So I need to type USB. In my case, I'm going to call this, what I'm actually doing there is I'm assigning it the name USB, so that's what this is going to be referred to from now on. And then the device UUID, so /dev/disk/by-UUID, just like you'd see in an FS tab, and then I'm going to paste in the UUID that I copied from earlier, and then the location of the key file, so /root/usb.key. Now notice it's called USB and my device is also called USB. That could be anything I want it to be called. It's not related at all. Okay? And then at the end of the line, LUKS. And that's all we need. Write it out, Control-O, and then Control-X to exit. I could reboot my computer now if I want those changes to take effect to my crypt tab, but I can also just start the drives as well, and that's going to make it, it's going to make it happen without having to reboot. So crypt setup, no, it's not crypt setup actually this time, it's crypt disks start USB is what I called this one. Crypt disks _ start. There we go. Crypt disks _ start USB. So now USB is in fact started. So if I go, let's just go into cd/home/Robbie. That's my home folder. I'm going to make a folder, make dir, and I'm going to call this one USB decrypted. Just so that you know what it is. You can call that whatever you want it to be. You might call it backup, for example. So now I'm going to go into that folder. We've learned this command before, but watch what happens. This is a folder on my computer, and it doesn't currently have anything mounted. So if I touch something, now that file exists. So I don't want that to be the case, because if I accidentally write something to that folder while the drive is unplugged and unmounted, it's going to then make it so that it can no longer necessarily access the mount point, or I'm going to get confused thinking that it's mounted and it's not because there looks like there's files.
Right.
So instead I'm just going to make it so that I'm going to remove that test file that I created so the folder is empty, and I'm going to go CHATTR+I dot, and the dot represents current folder because that's the folder that I'm in. So it did nothing to the folder, but watch what happens if I touch test again. Setting times of test, no such file or directory, ls, there's no file. It made it so that I cannot create files in this folder. Now once I mount the drive on it, now I'm going to be able to place files on the drive because it's not going to have that chatter. Okay, so let's open our FS tab. This is where things get fun, folks. FS tab, here we go. So now we're going to be using our mapper that is called USB. So we don't need to know the UUID anymore. That's all done through crypt tab. Now what we're going to use is the mapper/USB. So it's going to be a little bit different here. So we're going to, in our line here, you can comment if you want, but I'm just going to go /dev/mapper/USB. I keep wanting to type backup because that's usually what I call it. And then where I want to mount it. So we're going to go /home/Robbie, and this is going to be different for you, USB decrypted, I believe I called it. And then space, ext3 is, I believe, what we formatted it last week. ext3 and ext4 are interchangeable, so it's not going to hurt anything if I got it wrong between the two. That's okay. And then, here's where things get a little bit complex, folks. Defaults. All right, that seems pretty generic. No fail. That one's important to me. The reason is, if this drive is not presently mounted to my system and I reboot that system, if I don't have no fail in the mounting line on the FS tab, it's going to keep trying to mount that drive, and it's going to hang up the system and it won't be able to boot. It may time out after 1,000 minutes or something, but you don't want to have that happen. So no fail says, you know what, if it's not connecting, just move along, folks. Move along. And so that's a good thing to include on the line. Then, comma, RW, because we want it to be readable and writable, comma, user, comma, x-systemd, dot device dash timeout equals 5. Do you notice that? That works alongside of the no fail, as I was explaining, and this says, hey, if it does not connect within 5 seconds, move on. Thank you very much. And we do not want to scan it, so we're just going to put 0 space 0. Okay, hit Control O to write that out, and then hit Control X, and then type mount-A, keeping in mind that, again, I'm still super user, so I can just press mount-A. I don't need to use sudo. And I'm going to hit enter. This is the moment of truth, folks. Are you ready for it? We need some haunting music here. Here we go. Did nothing. Absolutely nothing! No, it did something, because there was no error.
Okay.
Right.
I was joking. That was a joke. LS. It's nothing. Thank you. I'll be here all night. Touch test. No such file or directory. Okay, so it's not mounted. Mount. Let's see what's happening. dev/mapper/USB mounted as ext3 on Robbie USB decrypted. That looks right. Umount USB decrypted. Let's look at the permissions here. Root. Okay. Mount-A. Nothing changed. There we go. See what happened there? Notice now there's a lost and found. So now if I go into it, touch test, now it works. And I'll show you why that was. I was in the folder when I typed the mount-A command. So it's like when something is locked and it can't do anything with it because it's currently in use. So right. For the sake of the demonstration, I was in the folder. You won't be when you reboot your system. So that's why it didn't work there. So by going up one folder, doing the mount-A again, now it worked. So did you notice a couple things here? I'm gonna quiz my hosts here. What was different about this time when I mounted it versus the first time tonight? Did you catch it?
No.
When I plugged in the USB drive the first time, what happened?
It asked for a password?
Asked for a password. When I typed mount-A, what happened?
There was no password.
No password requirement, my friends.
Yes to the cheat sheet.
Yeah.
You have a cheat sheet?
Oh, buddy.
All right, so there you have it, folks. So that drive is now all set. So now cd.umount USB decrypted. Now, if I look in there, there's not going to be any test file. Okay, so now I'm going to physically remove the drive. Okay, and we're going to plug it back in to my computer. Error unlocking. That's interesting. I wasn't sure what was going to happen from the GUI perspective. Interesting. So I think the GUI in this particular case kind of messes with the drive. Let's take a look here. Wrong FS type. What did we formatted last week? ext4 maybe?
Actually,
I'm looking
yeah.
back.
I think it was.
No, it was ext3.
Was it 3?
Yeah. So let's just see here. So it doesn't want to mount it in the GUI. Oh, you know what I did?
You didn't take a Luke stump?
I didn't need to. But what I didn't do is I didn't stop the cryptography on the drive. And I unplugged it. We got to think in terms of, now there's two parts to this. We've got cryptography and we've got mounting, like as a drive.
Right.
So what I need to do is crypt disks _stop USB umount. Okay, so now that that's done, I'm going to just umount just in case. I don't think it's mounted. Not mounted. Unplug. I've got it unplugged. I do. Plug it back in. Now. Crypt disks. Oh. I didn't even have to start it.
No, it just popped right up.
Okay, let's try that again, folks. Eject. I'm just going to eject that. I'm just going to unmount it, just like a normal USB drive.
See, and this is what's fun about a live show.
That's funny. There's a password required in order to unmount it. Oh, because it's root. Obviously. There we go. Okay, can I... Okay. Canceled, canceled, canceled. All right, let's close everything. There we go. We're back at square... Whoa. Nice. It's always fun having a camera guy. There's the flash drive. Okay. We're going to take this now, after our two-part demonstration, and I'm going to plug this in to the computer in 3, 2, 1. It's in.
Uh-huh.
Uh-huh.
There you go.
There's my test file. Did not ask for a password. And we're good to go. So now this drive, anything that I put on this drive, now it didn't ask me for a password on my computer, but it's going to ask, if you plug it into your laptop, Sasha, it's going to ask you for the password. You're not going to be able to open it.
Very cool.
There you have it, folks.
That's awesome.
Hope you enjoyed this this two-part series. This is a great way to protect your data. I always fear, you know, if you're doing backups, if you're keeping private stuff, and it doesn't have to be private. Like you think about private, and it's, you know, private, secret stuff. Well, no, I don't want someone getting their hands on a drive that's full of my family photos. It's kind of creepy, right? Like it's not that there's anything there. It's that it's kind of creepy.
Well, plus, I mean, you don't want anybody to be just picking up a drive and checking to see what's on it. So you might as well, you know.
And this way, I don't have to really worry about what's on it. Like it may have a spreadsheet with some of my passwords in it. It may have a spreadsheet that has some accounting data or something like that. And I feel a lot safer now that my drive is fully encrypted. So it works on my USB flash drive, perfect. It works on your external USB drive. It works on your internal hard drives. It works on your eSATA removable drive that you're hot swapping. It works on anything that you're going to be storing your data on Linux. So check it out.